Hi guys. Check out Batman and Robin, right? They're running in a straight line. So that's a linear, running linear. But the other guy at the back, he's all over the place. He's running non-linear, all right? So today we're going to study linear versus non-linear. Ready? Here we go. Okay, so today let's review what we learned in the past, and that's all about what is a function. Okay, and we learned that in a function, there's an input, there's a rule, and then there's an output. Okay, x becomes a y, will give us a value for y, and we remember that for every x, there should be exactly one y only, and the x is called the domain, the y is called the range. We know that. And whenever we make a rule, we can think of the pattern. We could write it as a function rule. And now look at these graphs. This is a straight line. This is a curved line and a curved line. Okay, they are all functions. Functions. Okay, but today our focus are linear functions. Linear. We want to know if it's going to form a straight line or it's not gonna be a straight line. Okay, so let's connect them, not just functions, but linear functions. Okay, and there are different ways to identify if they will form a straight line or not. Now, just by looking at these tables, I don't need to graph them. I will already know if they're linear or not. So it's already telling you the left side, the blue ones are linear, the right side are non-linear. So without graphing, how did I know that? Okay, look at this. Now, it's simply done by looking how did the number change. Okay, so -2 to -1, did it increase or decrease? Tell me. Not decrease, it increased. The more you go to 0, the higher it goes, right? So plus 1. Everything here is adding up plus 1. Okay, how about here? 1.5 to 0, it got lesser, so minus 1.5. Here, it got farther again, minus 1.5. Going farther again, minus 1.5. Check it out. The y, when you make a rate of change, you're comparing the change in the y over the change in the x. Check it out. Negative 1.5 over 1. The other one is negative 1.5 over 1. The other one is negative 1.5 over 1. They are always the same. So constant rate of change, I don't need to graph it. I am very sure it is going to be a line. Okay, let's try the next one. This one goes, okay, minus 1. It gets farther, right? Minus 1. And then this one will be minus 1. How about here? It increases by 1, increase by 1, increase by 1. So what's the slope? The slope start with a y, 1 over negative 1. The next one is 1 over negative 1. The next one is 1 over negative 1. They are always the same. Constant rate of change, no change. It's going to be a straight line, either positive or negative or another way. Okay, so we're good, linear. Now, let's look at this. How can it be non-linear? So if you look at the development of the number, this is plus 1, plus 1. This is plus 1. No problem with that. 0 to negative 2 is minus 2. Negative 2 to negative 1 is, hold on, negative 2 to negative 1. It's not minus. You're adding 1. Negative 1 to negative 3, it's getting farther. You subtracted 2. Now, if you look at this, is negative 2 over 1 the same with 1 over 1? Is it equal to negative 2 over 1? Look at this. If you write the slope, are they the same? No, they're not. There is no constant rate of change. Now, this is the change is plus 1. Okay, plus 1. This is plus 1. No problem here. How about here? Negative 2.5 to negative 5.5 is minus 3. How about 5 to 7.5? Yes, is minus 2. How about this one to that? 7.5 to 10? Minus 2.5. If you write down those rate of change, that's a negative 3 over 1. That's a negative 2 over 1. That's a negative 2.5 over 1. Are they equal? No, they're not. Therefore, it is not a straight line. Okay? So, non-linear. Okay? Just by looking at the tables, you will already know. Now, just by looking at the lines, okay, is it a linear? They're all functions, right? If you use your vertical line test, they're all functions, but I want to know which is linear, okay? So now, how do I know that? If the line, no, visually just by looking. If it's a straight line, no doubt, it's already a linear function, straight line. But if it is not a straight line, it has curves. Here it started out as a line, but the curve went up like that. So it's not a line. This started out as a line, but this started a line, but there's a curve over here. Therefore, it is not a linear. Remember, our focus is line. Will it form a line? Obviously, okay, graphs are easy to identify. Now, what if it's an equation? Okay, for an equation, you can either graph it or make the domain and the range and look at the numbers. But you ain't nobody got time for that. All right, so rule to know if an equation is linear or not. Number one, the power of x and y is either 0 or 1. Look at the exponent. Remember, if there is no exponent, it always has an exponent of 1. It's not a 0, it's always a 1. Remember that. Okay, exponent of 1, check. X has an exponent of 1. Exponent of 1, check. Okay, y has an exponent of 1. X has an exponent of 1. X has an exponent of 1. Y has an exponent of 1. They're all equation. Therefore, what? Exponent of 1 only. But 0, is 0 allowed? Yes, because if it's 0, it just becomes a 1. All right? So it cannot be more than 1. It cannot be more than 1. So that's one condition. Another condition. Here the exponent is 1. The exponent is also 1. But you cannot multiply the x and the y. This is a no-no. Even though the exponents are 1. So not a linear function. What else? Oh, Ram, the exponent here is 1. The exponent here is 1. But, check this out. X cannot be a denominator. The x cannot be under. These are the two exceptions. Remember that. X and y cannot be multiplied. Number two, x cannot be a denominator. But if the exponent is 0 or 1, we're good. It's a straight line. So if it's not a 1, if it's a 2, immediately I saw a 2, I saw a 2, it's not going to be a line. I saw a 2, I saw a 2, it's not going to be a line. I saw another 2, even though this is a 1, it's not a line. What if I see x to the third plus y to the 12? As long it's not a 1, it is not a line. So the power of x and y is either greater than 1. As long as it's greater than 1, it's not going to be a linear function. It will not form a line. Let's practice now. What is the rate of change of the function? Of course, it's a straight line, so it is a linear function. No doubt, just by looking at it. But the problem is, what is the rate of change? Remember, when you see the rate of change, that means slope. Remember, you learned before, slope is the y2 minus y1 over x2 minus x1. It is also the rise over the run. This is an old lesson that we learned in the past. Now, from this point, check this out. Okay, and another point here. I see another distinct point here. Okay, am I consistent? Is it consistent? All right, so what is the rise? Let's try to count. The rise is 1, 2, 3, run of 1, 3, 1. Rise of 1, 2, 3, run of 1. Rise of 1, 2, 3, run of 1. Am I consistent with it? Is it constant? Yes. A rise of 3 and a run of 1 is which one? The last one. Remember, if it has no denominator, it's always a 1. Okay, so now they're giving us a table. So let's read the problem first. Okay, The table below represents the amount of money in Sylvester's bank account. Money going up for every year. Okay. As a function of the number of years, meaning the money increases as a function of years. Every time the year increases, the amount of money changes as well. Okay, since he opened his account, does this situation represent a linear or non-linear function and why? Meaning if I graph it, will it be a straight line or not a straight line? Do I need to graph it, make a line, and then identify the x's and the y, 1 year, 500, and make all the points like that? Should I do that? You don't need to. Remember, you just look if it is consistent, constant rate of change plus 1. This is plus 2. This is plus 4. And this is plus 8. No problem with that. This goes up by 500. This goes up by 1,000 minus 500. 1,500 is 500. This goes up by 500. This goes out by 500. Okay? So, how look at it. You can already see. Is it consistently the same? 500 for the first change of time, 500 for 2 years, 500 for 4 years, 500 for 8 years. Are they a constant rate of change? Are they equal? No, they're not. Therefore, it represents a nonlinear function because there is not a constant rate of change. Next, so this is again by looking by visual. Visual, okay? Linear, does A represent, oh, which represents a linear function? Obviously, is this a line? No. Is this a line? No. Is this a straight line? No. So therefore, this is our correct answer. Okay, last. So, is the function in the graph nonlinear? Is it not a straight line? Well, obviously, does it look like a straight line? Okay, is it nonlinear? Do you agree it is a nonlinear? So the answer is yes, yes, but not these two. So I'm not gonna select no, no, but let's look at the reason. It is nonlinear because it does not have a constant rate of change. Yes, because it has a constant rate of change. So obviously the correct answer is what? It does not have a constant rate of change. Okay, now you know you can easily identify which one is linear and non-linear. Okay, so remember results is equal to action plus motivation. Good luck.